Hi students, good evening everybody students. Students, good evening everybody. Today I am going to discuss the previous EAMCET question paper. This is EAMCET 2021, 17th of September, shift 2. So before that students, I want to introduce you about Unacademy Plus subscription. Students, if you are a Plus subscriber, I think so you know the benefits over here. So otherwise you can observe the benefits that more than 10 batches every day will be launched, 250 courses, more than 2000 lessons, and these are the benefits, and top 20 educators will be always interact with you students. And already currently 2 batches are going on students. These are the top 20 educators. Okay students, let us start students about the batch, about this EAMCET question paper. See here that when a weight of 10 kg is suspended from a copper wire of length 3 meter and diameter 0.4 millimeter, its length increases by 2.4 centimeters. The diameter of the wire is doubled, then the extension in the length will be how much? See here that extension is inversely proportional to r square. So this concept, if you observe that Young's modulus is equal stress upon strain. Here stress is nothing but students force by area, and strain is change in length by original length. So this is the extension we can say. Since here area by r square under the same load, force constant, so the extension is inversely proportional to r square. So then L1 by L2 is equal to R2 square upon R1 square. L1 by L2 is equal to R2 square by R1 square. Then if you go for mathematical steps, you'll get the students. R1 is, let us suppose if you see students, please students, okay students, since extension is inversely proportional to r square, then L2 by L1 must be equal to R2 square upon R1 square. So L2 by L1 is equal R1 square upon R2 square. Here R1 is equal to R and R2 is equal to R. Then L2 by L1 is equal to R1 is R students, R2 is 2R whole square. So we can get over here that 1 upon 4 we can say. So finally L2 is nothing but L1 by 4. Since given that L1 is 2.4 by 4. 0.6 centimeters will get. So I hope so you understood, students, the first question. Similarly, students, second question, if you see over here, that two vessels A and B contains oxygen. The volume B is twice that of A. The pressure B is thrice that of A. And the temperature of B is half of that of A. Then find the ratio of number of molecules of oxygen in vessels A and B. Since you know that ideal gas equation PV is equal to nRT, then since PV is equal to nRT over here, PA VA upon PB VB is equal to NA by NB TA upon TB. So here pressure volume is directly proportional to N and T. So our P1 V1 upon P2 V2 must be equal to N1 T1 by N2 T2, we can say. Since the values they given, students, over here that two vessels of A and B contains oxygen, volume of B is twice that of A, pressure of B is twice that of A. So we can substitute over here that P by 2P and V by 2V is equal to NA upon MB. I'll take the next slide, students, over here. Please observe once. Since you can observe, students, over here, PV is directly proportional to number of molecules and then temperature. So P1 V1 by P2 V2 is equal to N1 T1 upon N2 T2. Here N1 by N2 is nothing but NA by NB, of course, students. Here pressure is P and volume is V by 2P and then 2V. Volume is double. N1 by N2 into. So what about the temperatures if you see now? T by 2 upon, sorry, in your T1 is T and here T by 2. T gets cancelled. So finally, if you simplify, students, over here, pressure is given 3 times of pressure. So V and then P gets cancelled over here. Then N1 by N2 is equal to 1 by 12. Actually, I had written double, students. The pressure is given 3 times. So that is the reason I have used over here. N1 by N2 is equal to 1 by 12, we can say, students. So I hope so you understood this question. So the next question, we'll move on to the next question. A body of mass 10 kg, constant velocity 10. A constant force is applied for a duration of 4 seconds on the object and gives it a speed of 2 meters per second in opposite direction. What is the acceleration? Since you know that acceleration is equal to rate of change of velocity. Since opposite direction over here, so we can mention over here that -2 -1, -2 -10 in 1 second. So that is -12 meters per second square. So then the force is equal to mass into acceleration. So your change in speed, students, this is a change in speed. Acceleration is equal to change in speed upon time, of course. So -12 upon 4. See here, students, the body of mass 10 kg, constant velocity 10, a constant force is applied for a 4 seconds duration. So actually time should be given 4 seconds over here. So 4 3s are. So we'll get over here that -3 meters per second square. Option 2 is the answer. So this related with Newton's second law, force is directly proportional to rate of change of momentum. So our change in momentum by time, or you can say over here that acceleration is nothing but change in velocity upon time, we can say. Since the question is asked directly over here, so the no need to use over here that. Suppose if the question asks for a force to find, then you can multiply with mass into acceleration. Yes, students, I hope so you got clear. So we'll move on to the next question. So I'm selecting some few questions today. The ratio of displacement distance for a moving particle. Students, if the object is moving in a straight line, the displacement and distance both equal. Displacement and distance both are equal in a straight line. If there is a curved path there is a shortest line joining from initial point to final point. Shortest line joining from initial point to final point. So displacement can be lesser than distance, or displacement can be equal to distance. So the ratio, if you observe over here, that displacement upon distance is always lesser than or equal to 1, we can say. Since it is always lesser than or equal to 1, so option 4 is the answer, students. 1 or lesser than 1, we can say. Then we'll move on to the next question over here, students. Students, I hope so everybody is getting clear. If any doubts, you can, any problem, please you can send in a live chat. When a body moves in a circular path, no work is done by this force. Why? Because in a circular path, the force experiences centripetal force. So the force is always act perpendicular to the displacement. So it is always equal to 0. So force and displacement are perpendicular to each other. So that is the reason the work done by this force is 0, we can say. Yes, students, it is anyhow conceptual question, of course. In a circus, a motorbike in a vertical circular path of radius r, find the minimum speed he must maintain at the highest point of the track. Students, it's a basic idea that at the highest point over here, that tension should be minimum. Since over here tension is minimum over here, and the particle should complete circular path, it has to cross this position over here. At this point speed is v. Since at this point speed is v over here, so can I mention over here that, so gravitational force mg is provided by necessary centripetal force mv square by r. So then v square is equal to rg. Then v is equal to under root of gr. So option 3 is the answer, students. Students, I am selecting few questions. Of 20 questions I am choosing now. The next 20 questions, the next session on Monday mostly I am going to discuss. So the variation of potential energy of a harmonic oscillator is shown in the figure. Then find the spring constant. Over here the question is given that find the spring constant. So at this point at t is equal to 0, there is certain potential energy is there. Generally we will consider that always at the mean position potential energy is 0. But for the given question, if you see there is some potential energy is there. So its potential energy is not equal to 0 at this point. Since potential energy is not equal to 0 at this point, what is the energy initially? 0.01 is there. Then at the extreme position potential energy, students, 0.04 is there. So what will be the change in potential energy if I ask you that U2 minus U1? So then you can mention over here that U2 minus U1 0.04 minus 0.01. We'll get over here that 0.03 joules, we can say, students. So here 0.03 joules. So whatever the potential energy is there, this is equivalent to half kx square, where x is the elongation. So what is the elongation is given, students? 20 millimeter is given. Since you know that half kx square is the elastic potential energy, so you can substitute over here that 0.03 is equal to half into spring constant into 20 millimeter square into 10 power minus 3 whole square. Then if you simplify, you can get the spring constant. Yes, students, getting clear? Please message students in a comment box. Yeah, definitely somebody is asking, students, when will TS EAMCET for medical stream comes? So definitely we will publish in coming days. Seema, we will publish definitely. I'll note down this thing and definitely I'll come in front of you. Okay. Strength of gravitational force compared to strong nuclear force. It's a conceptual question, students. You can remember minus 39, 10 to the power of minus 39, of course. Okay, students. So a cyclist comes over here, stop in 10 meters. During this process, the force on the cycle due to the road is 200 newtons. So directly opposite to the motion, means what you can say, students, it is like a friction, we can say. How much work does the road do on the cycle? If you see, students, very simple, work done by the friction, frictional force or applied force, displacement, cos theta. Since according to the given problem, there is a opposite direction is there, so theta must be equal to 180. Since theta is equal to 180, so we can write over here that work done is equal to 200 into displacement is 10 into cos 180 is minus 1. So minus 2000 joules, we can say. See, students, it's a very nice question. A fully loaded Boeing aircraft has a mass of 3.3 into 10 to the power of 5 kg. Sorry. Its total wing area is given 500 meters square. It is on a level flight with a speed of 960 kmph. So the pressure difference between the lower and upper surface. Students, it is very simple question. You know that pressure is equal to force upon area. Then the force is equal to, you can say, students, or force is equal to change in pressure into area, we can say. So then the pressure is equal to force is how much, students? 3.3 into 10 to the power of 5 and into 10 by what is the area is given, students? 500 meters square. Then if you simplify, you'll get the answer approximately this one, students. If you take G value is exactly 9.8, then as it is 6.5 into 10 to the power of 3 we'll get. Okay, students. One end of a string of length L is connected to a particle of mass M and the other to a small peg on a smooth horizontal table. If the particle moves in a circular with a speed v and tension is T in the string, then the net force on the particle will be. It's a very nice question, students. You can imagine that over here at this point the particle is moving over here circularly, if I say. So on this object or particle, what are the forces are acting? Tension, normal reaction, and then gravitational force mg. So here N and then mg will be cancels with each other. Only the tension is experiencing over here. So only the tension is experiencing. So option 1 is the answer. Yes, students. A radioactive sample. This is a paper 2 concept, students. I'll discuss in the next one more class. I'm going to keep. Okay, students. This is also paper 2 question, of course. I mean second year question. Paper 2 means second year students. Okay, students. Second year questions I am going to discuss, students, again. So an ideal Carnot's engine with an efficiency 30% operates between a source and a sink. The temperature of the source is 500 Kelvin. So 500 Kelvin that of the sink. So efficiency is equal to 1 minus T2 by T1. So T2 is the temperature of the sink, lowest temperature. T1 is the temperature of the source. So here efficiency is given, students, 30%. So 30 by 100, 1 minus T2 you require to find. T1 is 500. So gets cancelled over here that T2 by 500 is equal to 1 minus, students, 0.3, of course. So if you simplify, you'll get 77 degrees. Students, in terms of Kelvin, will get answer. After getting the Kelvin over here, please subtract with minus 273 degrees Celsius. Then the perfect answer you can get. So I hope you understood, students. It's a conceptual question, students. The diagram shows a stress versus strain curve for the material over here. That. So it's a conceptual question. So a ball is projected upwards from a height h above the surface of the earth with a velocity v. So the time at which the ball strikes the ground. Simple, students. Whenever the problem related comes over here, object is projected from the top of a building, top of a mountain, or from a certain height, whenever the problem comes over here, see, initial velocity is upward direction, and the particle reaches the highest point, again falls onto the ground over here. So then its displacement is h, we can say over here. So the displacement is downward direction minus h. If I say downward is negative, then upward will be positive, you can say. So initial velocity is positive, and acceleration, students, always at downward direction. Since you know that s is equal to ut plus half at square, so I can mention over here that minus h is equal to ut minus half gt square. Then h is equal to what we can mention, students, minus ut plus half gt square. Yes, students, now you can simplify that. U is nothing but v according to this question over here, minus vt plus half gt square, we can say. You can bring into a quadratic equation over here that gd square minus 2vt minus 2h is equal to 0. Since you know that quadratic equation expression minus b plus or minus root of b square minus 4ac upon 2a, then if you simplify, in place of a, g, in place of b, minus 2b, in place of c, minus 2h, then perfectly you will get this answer, students. Please, students, if any problem or any doubt, hi, everybody, hi. Students, I forgot to say hi. Hi, everybody, students. Okay? Thank you, students. Those who said hi to me, and for everybody, hi. See here, students. A force F bar is equal to 5i plus 4j acts on a body and produces a displacement this much. Find the work done by the force. Since, students, you know that work done is nothing but product of force and displacement. It's a basic idea. The definition of work done. So, since work done is equal to product of force and displacement over here, then W is equal to 5i plus 4j dot 6i minus 5j plus 3k, we can say. Then the work done is equal to over here 5 into 6 I dot I1 30, 4j minus 5j minus 20. So you will get over here that 10 joules, you can say, students. Here first law of thermodynamics is represented by, see here first law of thermodynamics says that dq is equal to du plus dw. So dq is equal to du plus dw. So dq is the amount of heat energy and du is the internal energy and dw is the work done, we can say, students. Since over here dq is equal to du plus dw, it is a consequence of conservation of energy. In this, du is a state function. So internal energy is always depends upon initial state as well as final state. So, and dq and dw are the path functions. It is depends upon path dependent functions. du is a path independent. So amount of energy whatever you are supplying, so it is utilized for internal energy as well as work done. Students, getting clear, students? Yes. The next. A disk of moment of inertia I1 is rotating with an angular velocity W1 omega 1. Another disk of moment of inertia I2 which is not rotating is gently put on the first disk. Then the angular speed of the system we have to find. Since you know that, students, angular momentum, conservation of angular momentum. So here that conservation of angular momentum. Hi Prince, how are you? Conservation of angular momentum, the total initial momentum is equal total final momentum. Hi Anand, how are you Anand? So initial angular momentum is equal final angular momentum, students. So I1 omega 1 must be equal to I2 omega 2. Generally we will say, students, I1 omega 1 is initial angular momentum and I2 omega 2 is final angular momentum. So a disk of moment of inertia I1 and its angular velocity is omega 1. So I1 omega 1. Another disk of moment of inertia I2 is not rotating. Since it is not rotating, its angular velocity is 0 plus 0 and it is gently placed on the first disk. So the total moment of inertia, students, I1 plus I2, we can say over here that I1 plus I2 into omega dash, new angular momentum. So the omega dash is equal to, what can I mention, students? I1 omega 1 upon I1 plus I2, we can say. So the perfect answer is, second option is the perfect answer. Yes, students. Okay, students. Mostly this question is repeated many times in previous entrances. So, which of the following said concurrent forces means resultant force should be 0. So, it is in equilibrium, you can say. So, concurrent forces, if you observe, students, when you consider two forces over here, let us suppose A and B are two forces, if I say, then always the resultant, students, should be between A plus B and A minus B. Resultant is always between A plus B and A minus B. So if I say over here 3 and 5, so 3 plus 5 and 3 minus 5, 8 and then 2. But it is given result third is 10 newtons, means this option is not correct. Here also same thing, students. 3 plus 5, 8, 3 difference with 5, 2. So it is also wrong option. So 3 plus 5 is 8 and 5 difference with 3 is 2. So whatever the third force is there, it should be comes in middle, means between 2 and 8. Since it is between 2 and 8, if you see over here, that third option is absolutely correct. Suppose if you see fourth option, 5 and 3, students, 8, 5 and 3 difference is 2. 15 is out of the resultant. So lesser than, greater than maxima and lesser than minima cannot be possible. So since it is cannot be possible, so first, second, fourth is not possible to make a equilibrium. So third option is correct. Yes, students. Okay, students, very nice question over here. What is the phase difference between the two particles 25 meters apart in a wave represented by the equation? So this is the wave equation. So standard equation, if you see now, students, A sin omega t minus kx, we can say. So in this equation, y is equal 0.03. Sometimes amplitude questions will be asked, students, that is equal to 0.03. And sine of 2 pi t minus 0.01 pi x, you can say. So if you compare over here, k is equal 0.01 pi. So since, students, k is nothing but 2 pi by lambda is equal, it's a wave number, you can say over here. Pi gets cancelled. Then finally, lambda is equal, will get, students, 200. Yes, students, lambda wavelength is equal to 200 we will get. Then the phase is equal to 2 pi by lambda into path difference, we can say 200 meters, of course. Then phase is equal to over here 2 pi by 200 into path difference, how much, students? 25. So 25 already given the problem over here. So 25 8 times 2 1s are 2 4s are. So finally you'll get phase as pi by 4, we can say. Yes, students, got clear everybody? Phase difference is equal to 2 pi by lambda into over here that path difference. Here path difference is over here 25 meters is given. I substitute and then we'll get the answer. The next question over here, that a weightless bag is filled with, very nice question. This is 5 kg of water and is weighed in water using a spring balance. The reading of the spring balance must be equal to 0, because that, so whatever the amount of volume it is spelled out equal to the bag volume, the density remains same over here. So exactly weight and then beyond force remains same over here. That net force will be cancelled with each other. So its apparent weight is equal 0, we can say, because upward force, beyond force, and then weight, both are anyhow same, we can say over here. Yes, students, the ratio of specific heats at a constant pressure and at constant volume is gamma. Find out the degrees of freedom you have to find, students. So here degree of freedom you require to find over here, that since it's a standard formula, students, gamma is equal to 1 plus 2 by f. So here f represents the degrees of freedom. So here is the question is given that generally most of the times we used to see that monoatomic gas, diatomic gas, triatomic gas, they will give you, find gamma they will give. So now the question is reversely they are asking that, f only they are asking. So gamma minus 1 is equal to 2 by 5. So f is equal to how much, we can say, students? 2 upon gamma minus 1, we can say. So this is first option, directly we can choose. Yes, students, any doubts? Any doubts, students? I hope so you are all understanding well, students. If any issues, kindly send me a message. So definitely I am observing over here. And what are the chapters you want also? You can see, students, please follow in a in an Unacademy app we are publishing the different classes, so definitely will come in front of you with those chapters. So if you follow the special classes, so you can watch and you can enhance your knowledge. Students, the last question I will discuss over here, that find the centripetal force acting on a coin weighing 0.1 kg placed 0.1 meters from the center of the gramophone disc rotating at 600 revolutions per minute. Students, over here that the force, centripetal force is equal to mr omega square, and the force is equal to mass is 0.1 kg and radius is 0.1, and omega, if you consider students, 600 revolutions per minute. So 600 revolutions, 600 into 2 pi, we can say 600 into 2 pi per minute by 60 whole square. 60 tens gets cancelled, then finally you will get over here that F is equal to 0.1 into 0.1 minus 2, 10 square is 100 into 4 pi square. So 100 minus 2 gets cancelled, finally you will get the answer as 4 pi square, will get the answer 4 pi square Newton. Find the centripetal force. Students, today whatever I haven't discussed, please students, I am going to come in front of you mostly on Monday. Please follow Unacademy, please subscribe the Unacademy YouTube free channel. Definitely will get all the updates, not only my class, different classes you will get. So the problems whichever I haven't discussed, I am going to come in front of you on 12th of this month. Okay students, so thank you one and all, thank you very much, those who are presenting me, those who are watching my class continuously. So thanks a lot students, one and all, thank you very much.